Quant questions. This week we'll be looking at questions from inequalities and modulus and even a little bit of functions, all sorts of questions. Let's get through them one after the other. First one, if 20x is less than y, and 23 times of x minus 1 is greater than y, and 21x plus y is equal to 500, x and y are both positive integers, the value of x is. Okay. First thing you have to do is, first we look at this equality. This is our starting point. Y is equal to 500 minus 21x. And we go ahead and replace them in the first two inequalities. The first inequality gives us 20x is less than 500 minus 21x, or 41x is less than 500, or x is less than 410 plus 90. So 12 point something something. Precisely, we don't know. Secondly, we have 23x minus 23 is greater than 21, 500 minus 21x. We bring it over to the other side. We get 44. X is greater than 523. Now 440 plus 88. 440 plus 88 will get me to 528. So x has to be greater than 11 point something something. Now x has to be less than 12 point something something. X has to be greater than 11 point something something. And x and y are both positive integers. So the only acceptable value of x will be x equal to 12. For the value of x equal to 12, y will be equal to 500 minus 21 into 12. 20 into 12 is 252. So y will be equal to 248. Although this was not needed for the question only asked me the value of x, which is equal to 12. We can also figure out the value of y. And then you can potentially see 20 into 12 is less than 248, and 23 into 11 will be 230 plus 23. 253 is greater than 248. Yes, everything is satisfied in the question. Answer is of course 12. Now next question. This is more theoretical. A mod is less than B mod, and B mod is less than C mod, and B is less than A is less than C. And which of the following are necessarily true? Okay. Just looking at these two. If B is less than A, but A mod is less than B mod, this can only happen if B is a negative number. If B is a negative number and its absolute value is greater than that of A. If its absolute value is greater than that of A. So we can be absolutely certain that B is a negative number. B is a negative number. Because if B was a positive number, see, if B was a positive number, A would have to be a positive number. And then their mod would return the result that A mod is greater than B mod. This is only possible if B is a negative number. A itself could also be a negative number. A itself could also be a negative number. A could be a positive number. A could be a negative number. Both of those possibilities are open. But B definitely has to be a negative number. Okay. Now let's look at this result. And mod B is less than mod C, and B is less than C. It would imply both B and C. One possibility is both of them are positive, or both of them are positive, or B, but this is not an acceptable case because we have already established B has to be negative. So B has to be negative, and it is less than C, and it is also less than B mod is also less than C mod, which would imply C's value is greater than that of B. C's value is greater than that of B, and the absolute value of C is also greater than that of B. So what we would get out of this is C has to necessarily be positive. It has to be greater than the positive version of B. It has to be greater than the negative version of B. In both the cases, C has to be positive. C is most definitely positive. Then which of the following are necessarily true? 2 and 3 will necessarily be true. I can go ahead and prove that A could be positive or A could be negative. Both of those are possible. Let's say if I take the value of B as -8, A as -2, and C as 10, every condition would be satisfied. Mod A is less than mod B. Yes. Mod B is less than mod C. Yes. And B is the smallest one. A is the middle one. C is the largest one. We could also have -8, 2, and 10. Even here, everything would be satisfied. So the value of A being positive or negative, we cannot be certain, but C has to be positive. Therefore, the correct answer here has to be option C. Next one then. Find the range of all values of x if 2x plus 3 mod is greater than equal to 7. Now, there are two ways in which this can be solved. The first way is equation-based way, wherein we break it down into two parts. 2x plus 3 is greater than equal to 0, in which case 2x plus 3 is greater than equal to 7 also. And then 2x has to be greater than equal to 4, or x has to be greater than equal to 2. Now, this is when 2x plus 3 is greater than equal to 0, then x has to be greater than equal to 2. From here, we get the condition 2x is greater than equal to -3, or x is greater than equal to -3/2. Yes, x greater than equal to 2 fulfills this condition. So 2 is one limit we have identified. 2 is one limit. X has to be greater than 2. Now, the other version is, right, 2x plus 3 is less than 0, or 2x is less than -3, or x is less than -1.5. In this case, what would happen to the mod expression is we would get -2x minus 3 is greater than equal to 7. We bring it over to the right hand side. Bring this entirely over. -2x to this side, -7 to this side. So 2x is less than equal to -10, or x is less than equal to -5. So given that x had to be less than 1.5, anything -5 or lower than that is acceptable. So the range that we have identified on the number line, the range that we have identified is -5 and everything beyond, and 2 and everything beyond. Both these ranges are acceptable. So the correct answer will be option D. This is the equation-based way of solving it. Now, the graphical way of solving this would be something like this. The line for 2x plus 3 will have its root at -1.5. And from here, there will be a line going upwards at the rate of 2. And there would be another line going here at the rate of -2. Now from -1.5 in order to get to 7. Now from -1.5 in order to get to 7, you would have to travel 8.5. You would have to travel 8.5. Yeah. Acha, we have to also make a line y equal to 7. In this part, we have 2x plus 3. In this part, we have -2x minus 3. Now, from -1.5 getting to 7 would mean traveling how much? Or even from the shape of this graph, can you see everything beyond this point is going to be acceptable, and everything beyond this point is going to be acceptable. So we are going to get two distinct ranges. The only option that has two distinct ranges will be this. We can solve it this way. Another way, from 0 to 7. From 0 to 7. See, the value of x here is 1.5. The value of the function itself is 0. From 0 to 7, This 8.5 is useless. From 0 to 7 at the rate of 2, you need to take 3.5 steps rightwards. Or from 0 to 7, you need to take 3.5 steps leftwards. Which will again lead you to the same values. 3.5 step rightwards from minus 1.5 will take me to 2. From 2 onwards, everything would be acceptable. And 3.5 steps leftwards from minus 1.5 will lead me to minus 5. Everything beyond minus 5 would be acceptable. And therefore, the acceptable range will be option D as given here. Although you did not need this 2 and minus 5, just the fact that there are going to be 2 distinct ranges in which this is possible should have been enough for us to arrive at the answer option D. Next, find the range of values of x that satisfies x minus 16 mod is greater than x square minus 7x plus 24. Okay. Now see, again, I am very, very partial towards solving it via graphs because graphs are something I understand very well. Graphs are something I understand very, very well. So I'm very, very partial towards solving it via graph, and that is the path I'm going to take here. Let's say this is the x-axis. Now, the two roots here that I'm seeking, 2 x square minus 7x plus 24. I can break it down as 24 को दो parts में तो होना है जो 7 का difference दे दे, 7 का sum दे दे, not possible. So I'll break it as x square minus 7x plus 12.25 plus 12.25 plus 11.75. So this is x minus 3.5 whole square plus 11.75. So at x equal to 3.5, we're going to have a graph something like this. The value of the function here is going to be 11.75. The value of the function here is going to be 11.75. Now the graph for x minus 16 mod, it will have one root at 16. It will have two parts, one going this way at the slope of 1, one going this way at the slope of 1 again, or slope of minus 1. So this is the part, and this is the part where they will meet. Now see, what this implies is both these meeting points would only be in the negative version of x minus 16. So I can directly rewrite it as 16 minus x is greater than x square minus 7x plus 24. I bring it over to this side, x square minus 6x plus 8 is less than 0. Or from here, I'll get x minus 2 and x minus 4 has to be less than 0. The two critical points, what we have identified are 4 and 2. Anything within this range would be acceptable because beyond this range, see, the quadratic function is higher. Beyond this range, the quadratic function is higher. Only within this range is the modded function higher. So the 2 points are 2 and 4, which leads us to the correct answer of option D. I am partial towards graphing, and therefore I solved it this way. Otherwise, of course, the standard solving mechanism would be if I take x minus 16 greater than equal to 0, x being greater than equal to 16. In that case, you will have x minus 16 is greater than x square minus 7x plus 24. Bring it over to this side, we'll have x square minus 6x plus 40. Sorry, minus 8x. So minus 6x plus 40 has to be less than 0. And we will see that this is not possible. This is not possible because this will be x square minus 6x plus 9 plus 31 is less than 0. This is x minus 3 whole square plus 31 being less than 0. This is an impossible state to be in. A perfect square plus 31 will always be greater than 0. So this is not possible at all. No cases get generated here. The alternative being x minus 16 is less than 0. So x is less than 16. If x is less than 16, then we have 16 minus x is greater than x square minus 7x plus 24. Then we bring it down to x square minus 6x. I have made a mistake. This will not be 6x. This is not the expression that gets created. Right? This x will come here and make it minus 8x. So x square minus 8x plus 16 plus 24, or x minus 4 whole square plus 24. The net result doesn't change. That remains the same. It is still unacceptable. But here, x square minus 6x plus 8 is equal, sorry, plus 8 is less than 0, which would imply x minus 2 and x minus 4 has to be less than 0. So the two turning points are 2 and 4. Both of those are less than 16. So yes, the acceptable range will be option D. This is the equation-based way of doing it. I am more partial towards graphical way because graphs give me a very clear picture of what is happening with the functions. Okay, next question. If x, y, z are positive numbers and x, y, z is equal to 216, which of the following is not a possible value of x, y plus y, z plus z x? Now, for such questions, the hint or the idea I want to give you is, see, we've been told they're positive numbers. We have not been told they're integers. So we can have one very large number. We can basically play around with numbers and reach our answer. We can play around with numbers and reach our answer. If I take the two numbers here to be 36, 6 and 1. If I take the numbers to be 36, 6 and 1, I can get to lots of cases. We can keep them very, very far apart. We can keep them very, very close together. We can keep them very, very far apart. We can keep them very, very close together. So very, very close together would mean all three of them being 6, in which case we are going to get xy, yz plus zx. xy, yz, zx will be equal to 108 then. 36 plus 36 plus 36. This is one limit identified. If this is one limit identified, you can see that above this limit, there are 3 numbers. Below this limit, there is just 1 number. This will be the answer. This will be the answer right away you can buy. But in case we want to get into, how are other cases coming into play? We'll also look at, let's say if I take x as 216 and y is 1 and z is 1, then you will see xy will be 216, yz will be 1, zx will be 216, in which case 216 plus 216 plus 1, 433. Can you see anything from 108 to 433, everything will be possible depending upon how I manipulate. So if 433 is possible, anything in the range 108 to 433 is possible. These two will also go away. By extension, option D will be the answer. Now, if we are also, we want to do it technically. We want to do it absolutely technically. We can do it by AM is greater than equal to GM, given that we've been told they're positive numbers. AM greater than equal to GM can be done. So we will have cube root of xy into yx into zx has to be less than equal to xy plus yz plus zx by 3, which will now give us xy by zx will be 216, 216 square. 216 itself was 6 cube. 216 itself was 6 cube. So I can break it down as 6 raised to the power 6 divided by 3, or 6 square. So xy plus yz plus zx has to be greater than equal to xy plus yz plus zx has to be greater than equal to 3 into 6 square or 108 xy plus yz plus zx. So all potential values of xy, yz and zx have to be greater than 108. That will enable us to reach to the answer. Option D is 96. While this is a fun thing, when this is true and this is accurate, remember, there is an inherent challenge here, which is why I prefer not to go down the path of AM is greater than equal to GM is greater than equal to HM. That potential challenge being, this is only valid for real positive numbers. So I'm more inclined and more dedicated towards utilizing the idea. Let's keep the variables very close together. Let's keep the variables very far together. With practice, you also realize close together and far together, there could be multiple cases within that itself. Here, I've got one case of 216, 1 and 1. This is far apart. I could also have another case of 432, half and 1. Even this is possible. And see what would happen with this. 432 into half will give me 216. Half into 1 would give me half. And 432 into 1 will give me 432. So I can go beyond 433 also. I can go beyond 433 also. But it is just that I know how to keep them even further apart. Even if I take this as half, and that will make this 864, I can get an even bigger result. I can keep on expanding the result. But there is no limit to this. But this is a limit. Because this is a limit, either maxima or minima will lie here. And we are seeing with the other side, when we are moving towards keeping them further apart, we are getting bigger results. At minima, at this point, we are getting the minimum result. So this is the minima, which is 108. And therefore, D is the answer. This is more reasoning-based way of doing maxima minima versus the more formulaic way. The formulaic way or the AM greater than equal to GM thing works only for positive real numbers, and therefore it is not my preferred go-to mechanism. Next, the number of integral values of x that satisfy the inequation x minus 3 plus x minus 4 is less than equal to 7. Again, I prefer going down the graphical way, wherein I see this is 4, this is 3. The two behavior change points are 4 and 3. On the right hand side of 4, both these functions would be positive. So I'd have a slope of plus 2 between these 2 points, between 3 and 4. Here, x minus, let me do this in entirety. I will have positive versions of both the functions, x minus 4, x minus 3. Here I would have positive version of x minus 3, but negative version of 4 minus x. Here I would have 3 minus x and 4 minus x, which means, can you see, in this range, the slope is going to be of plus 2, 2x minus 7. In this range, it is going to be 7. It is going to be precisely 7. And within this range, the slope is going to be of minus 2. This is how the graph would look. Now, we don't really need to figure out precise, as in this entire expressions everywhere in order to figure out the slopes. For slopes, all we need is on the right hand side of 4, I will have plus 1, so slope is 2. Between 3 and 4, plus 1, minus 1, so slope will be 0. And on the left hand side of 3, slope will be minus 2. This is done. Now at x equal to 4, what will be the value? At x equal to 4, what will be the value? I'm only looking at this expression right now. 7 is not even in my consideration. At x equal to 4, this will turn to 0, and this will turn to 1. The value obtained here will be 1. Because the slope is 0, the value obtained here is also 1. Now, y equal to 7 line will be like this. This is y equal to 7 line. From 1 to 7 at the rate of 2. From 1 to 7 at the rate of 2, you have to take 3 steps. So, this will be possible when we are getting to 3 steps to the right of 4, which gets me to 7. Similarly, from 3, the value here is 1. I want to get to a value of 7. It will be 3 steps to the left, or x will assume a value of 0. So the acceptable integral values of x will lie in the range 0 to 7, which are 8 numbers in total. And therefore, the number of integral values that satisfy the equation, the answer to the question will be 8. You can solve it graphically. The other way to solve it, of course, is break it down into 4 cases. When x minus 3 is greater than equal to 0 and x minus 4 is also greater than equal to 0. In this case, what would happen? Then x minus 3 is less than equal to 0 and x minus 4 is greater than equal to 0. Then what would happen? Then x minus 3 is greater than equal to 0 and x minus 4 is less than equal to 0. Then what would happen? And finally, we have x minus 3 is less than 0 and x minus 4 is also less than 0. Okay, see, because this is not a method I employ very frequently. I even made the mistake of less than 0 ki jagah I wrote it as less than equal to 0, which is not accurate. Now here, the function would open up to 2x minus 7 is less than equal to 7, or 2x is less than equal to 14, or x is less than equal to 7. We have found one acceptable limit. Everything is fine here. In this case, what would happen is I would have 3 minus x plus x minus 4 has to be less than equal to 7, which gives me x and x get cancelled. This doesn't really help me because minus 1 is less than equal to 7. While this is true, this does not help me identify the range for x. Okay. Coming here, we get x minus 3 plus 4 minus x is less than equal to 7. So from here, we get 1 is less than equal to 7. While this is again true, this does not help me identify the range of x. Here we will get 3 minus x plus 4 minus x is less than equal to 7. So we get 2x is greater than equal to 0, or x is greater than equal to 0. One range point for x is identified here, one range point for x is identified here. So within this range, whatever is acceptable from 0 to 7, there are going to be 8 integral values. Now, this is a simple version of the question. This is a very, very simple version of the question. The roots are integral, numbers are cutting out very easily. The slopes of the functions are also identical. So even doing it by this way does not lead to a lot of pain. But as soon as you start introducing more complexity into it, the graph is a much better way, much more efficient and much more reliable way of getting to the answer rather than solving it via cases. Okay, next question. Which of the following is R2? 15 factorial square is less than 15 raised to the power 15. 12 raised to the power 12 is less than 12 factorial square. And 18 factorial square is less than 18 raised to the power 18. So understand the way options have been framed or the way options have been given to us. They're very similar in nature. So you can potentially identify a trend Let's look at this. 1 factorial square and 1 raised to the power 1. Can you see they are equal? 1 factorial square and 1 raised to the power 1 are equal. Similarly, 2 factorial square and 2 raised to the power 2 are also equal. 3 factorial square, 6 square, and 3 raised to the power 3. 6 factorial square is 36. So it would mean this is larger. Now, how about 4 factorial 24 square is 576 and 4 raised to the power 4 is 256. This is larger. 5 factorial square is 144 followed by 2 zeros. And 5 raised to the power 5 is 3125. Significantly larger. Not only is it larger, can you also see from 3 factorial square, 3 cube, to 4 factorial square, 4 raised to the power 4, 5 factorial square, 5 raised to the power 5. The gap between them is also rising. And if this trend is going to continue, can I say 15 factorial square will be greater than 15 raised to the power 15. But this says the reverse. Similarly, option C, 18 factorial square will be greater than 18 raised to the power 18. But this option says opposite. This is the only option that falls in line with the trend that we have identified. Now, takeaway wise, see, n factorial square is greater than equal to n raised to the power n. Equality is at n equal to 1 or 2, but beyond all those points, n factorial square will be greater than n raised to the power n. This is a very, very useful result, helps us in solving questions. It is very similar to another result. Let's say a raised to the power b is greater than between a raised to the power b and b raised to the power a, wherever power is higher, that expression is larger. But then this also has a caveat. This is true for beyond 4. Because there is just one solution case where a raised to the power b is b raised to the power a, where a and b are distinct. The only possible solution case is 2 raised to the power 4 is equal to 4 raised to the power 2. This is the only possible solution case when a and b are distinct and 2 raised to the power 4 is equal to 4 square. And where this is not true is, let's say, 2 cube and 3 square. Although this has a higher power, it is less than 3 square. But beyond this point, beyond 2 raised to the power 4 and 4 square, look at any two numbers. Let's say 71 raised to the power 2 and 2 raised to the power 71. This will be larger. Wherever the power is larger, that number will be larger. These are basic insights. If you know these, it's not like you need to know them. These are observational trends. Once you observe them, they should be carried forward in whatever list of insights you are making for your CAT code. Okay. 3x minus 7 is less than or equal to 6x plus 8. And 2x minus 5 is greater than or equal to 7x plus 10. And the range of values of x that satisfies the inequalities is very simple. We bring it to 3x is greater than or equal to minus 15, or x is greater than or equal to minus 5. Okay, from here we will get 5x is less than or equal to 5x is less than or equal to minus 15, or x is less than or equal to minus 3. So we found our two limits for x. Starts off at minus 3, ends up at minus 5. The acceptable range, the option A. Next, if x lies in the range minus 3 to 5 and y lies in the range minus 7 to 12 and z is equal to 3x minus 4y, then which of the following is the range of z? Okay. Z is equal to 3x minus 4y. 3x minus 4y. Now, let's say we are looking to maximize z. What is the largest value x can take? The extreme absolute largest value x can take is just under 5. So let it be 5. 3 into 5. Now from this, we are subtracting 4y. But I can maximize this. I can either take 4 into 0, or I can maximize this by doing minus 4 into minus 7, which gets me to 4 into 7. So I get a 15 from here, and I get a 28 from here, which gives me the absolute maximum of z will be tending towards 43. 43 can never be achieved, but the absolute maximum of z will be tending towards 43, which at this point will rule out these two numbers. Clearly, it will rule out these two numbers. Now, more fun thing, you can also rule out C. You can also happily rule out C, because see, 3x I can definitely get a negative. 4y I can definitely get a negative. which would imply the smallest possible value of z being positive is not possible. We can rule it out. We can mark it. How to get to that minus 57? You can look at it. 3x, I want it to be very small. So I will take x equal to minus 3. So 3 into minus 3 minus 4 into 12, which gets me to minus 9 minus 48, or gets me to minus 57. Z can go from minus 57 to 43. It cannot achieve these two values. It cannot achieve these two values. They are just beyond the acceptable range. But these two values can definitely, as in, these are the limits that are identified. Answer to the question will be option A. Next, the range of values of k for which this expression is less than 0. Or let's go on to say x square minus 3kx minus 5k plus 1 is greater than 0. Now, what does this imply? What does this imply? This implies, regardless of what value of x I put in, I will always get a positive result, which means the function never cuts the x-axis, which means the roots are imaginary. If the roots are imaginary, the discriminant has to be negative. So let me write down the discriminant, minus 3k. So 9k square minus, so this will become 4 times of 5k plus 1 has to be less than 0. B square minus 4ac will be this. So 9k square plus 20k plus 4 is less than 0, which will then give me 9k square plus 18k plus 2k plus 4 is less than 0. 9k taken out common, left with 2k, sorry, left with k plus 2 times of k plus 2 has to be less than 0. So 9k plus 2 and k plus 2. These are the two terms in the factorized form, which means our k can go from minus 2 by 9 to minus 2. Anything within this range is deemed acceptable. These two values are not acceptable, but anything within this range is acceptable. Now, the option that gives me anything within this range is option C. So that will be the answer to this question. Okay. The interpretation of the fact that the roots will be unreal, and therefore I have to look at b square minus 4ac is critical for this question. Moving on. Minimum of these two and minimum of these two. Okay. First, look at this min function. From this min function, x plus 6 is always going to be greater than x minus 3. So this will always return x minus 3. And of these two, x plus 5 will always be greater than x minus 7. So this will always return x minus 7. And between these two, which one is larger? Clearly, x minus 3 is larger. So option C will be the right answer here. Next, for a real number x, let this bracketed x denote the greatest integer less than or equal to x. The number of real solutions to 2x minus this portion x is equal to what? Okay. So we've got, let's say x, the variable x is equal to the integral portion and the decimal portion. This is how the standard notation works. Then we will have number of real solutions of 2 times of this x plus 2 times of this x minus integral part of x mod of this is equal to 4, or the integral part of x plus 2 times the decimal part of x has to be equal to 4. Now, this here, if I put down x equal to 4, from here, if I put down x equal to 4, can you see there is no decimal part? So it works. This is an acceptable value. This is definitely an acceptable value. Additionally, another way we can reach here is if x is equal to 3.5. If it is 3.5, x equal to 3.5, this will return the value of 3.5. 2 into 0.5 will give me 1. So this will also work. This will also work. Now, let us look at the negative world. Let us look at the negative world. If I take x equal to minus 4, if I take x equal to minus 4, no decimal part, yes, it definitely works. This is also fine. But when we are looking at the negative world, we would have to look at, if I take minus 3.4, see, if I take x equal to minus 3.5, then mod x will be, or this portion will be equal to minus 4, and bracketed portion will be equal to 0.5. This is how it breaks down. Minus 4 and 0.5. This decimal portion will always be positive. So if I put it minus 3.5, then what would I get? I would get minus 4 plus 1, which is not equal to 4. So this doesn't work. Here it doesn't work. But then what do we have to plug in? Not minus 3.5, plug in minus 4.5. Plug in minus 4.5. Then what will we have? The integer part is going to be minus 5 and the decimal part is going to be 0.5, which gives us minus 5 plus 1 mod is equal to 4 indeed. So this also works. So how many real solutions are available for x? How many real solutions? There are 4 real solutions possible. The answer to the question is 4. Next, what is the minimum value of the function? X minus 1, x minus 2, and x plus 4. Graphically, if you solve it, if you can see it graphically, or at least you're comfortable with graph forming, then the process will be very simple. On the right hand side, the slope is 3. Between 2 and 4, the slope is 1. Here the slope is minus 1. Here the slope is minus 3. So our graph will go something like this. Then here, and then here. The minimum point will be obtained at x equal to 2. So for a, x equal to 2, if I put down, this will be 1. This will be 0. This will be 2. So the minimum value of this function will be equal to 3. Now you don't need to draw a graph every time. See if there are odd number of modded terms, whatever is the middle value, whatever is the middle mod function, take x equal to that, your work will be easy, it will be done. Now for the second one, again, graphically, first time when you are solving it, graphically, you can perhaps see what is happening. 1, 2, 4, and 8. Right hand side, slope is 4. Here slope is 2. Here slope is 0. Here slope is minus 2. Here slope is minus 2. So how would the graph look like? This is how the graph would look like, which means in this range from 2 to 4, any value of x that I take, I will get my minimum value of the function. So let me take x equal to 2. This will give me 1. This will give me 0. This will give me 2. I'm simply repeating values from earlier. And here I will get a value of 6, which tells me for A, the answer is going to be 3, minimum value of the function. And for B, the minimum value of the function is going to be 9. Again, you don't need to draw a graph every time. All you need to see is What is the middle value? The middle value here is this. The middle value here is this. Now, this is a very easy question because the terms are also lined up in ascending order. Even if they were turned around, even if they were not in the right order, the middle root, the middle behavior change point is what we are going for. As soon as we plug that in, we will get the minimum value of this model function. Next, the number of integral values of x that satisfy the inequality 2x minus 19 minus 7 is less than equal to 5. Okay. Again, solving it graphically is smart. See, graphically, first we'll draw a graph for 2x minus 19 mod, which means the root is going to be at 9.5. Slope of 2, 2 and minus 2. This is the model function. From this, I subtract 7. So at 9.5, I'll get a value of minus 7. The graph will be created this way now. Like this, two parallel lines will go. Here, the value of the function is minus 7. But because we are modding this, final version of the graph will be like this. It will be a W shape. This local maxima will occur at 9.5. Here, the slope is 2. Here, the slope is minus 2. From 7, I have to come down to 0. I have to come down 3.5 steps. 3.5 steps to the right will be 13. I have to come down 3.5 steps here also. The value here will be 6. The two roots are going to be 6 and 30. Now, we have to identify where all this inequality is less than 5. Then, here the value is 7. So, at 5, it is going to be in this range. This will be the line of y equal to 5. From 0 in steps of 2, you have to reach a value of 5. At x equal to 6, value of the function is 0. At x equal to 6, value of the function is 0. You can perhaps plug that in, or at value 13, x equal to 13, the value of the function is 0. So from 6, moving in steps of 2, you have to reach a value 5. You have to take 2.5 steps, or this is going to be 2.5 steps leftwards. So 3.5. And here it is going to be 2.5 rightwards. So 8.5. Again, here also and here also 2.5 rightwards and 2.5 left. 2.5 steps rightwards and 2.5 steps leftwards. 2.5 leftwards will get me to 10.5. And here it will be how much? 15.5. So see, the acceptable ranges are 3.5 to 8.5. Numbers that can be taken up are 4, 5, 6, 7, and 8. And here the acceptable numbers are going to be, let me write it nicer, 15.11, 12, 13, 14, and 15. Or altogether, number of integral values of x that satisfy this inequality are 10. There are 10 values of x that satisfy this inequality. Again, solving it graphically leads me to this diagram. Of course, making this diagram requires a lot of practice and basic theoretical understanding. In the absence of which, I would have to make so many cases. First, 2x minus 19 is greater than 0, 2x minus 19 is less than 0. Now, within that, I have to branch out. 2x minus 19 minus 7 is greater than 0. 2x minus 19 minus 7 is less than 0. Basically, 4 cases I would have to draw and then do it. And in a graph, I can happily do it in this much work. This is not easy. This is, of course, a slightly complicated. For most of us that don't study graph, this is going to be very, very lacking. But then those of us who do study graph, who have studied graph for CAT, and you should, most definitely should, if your insti has not taught you graph so far, ideally you should force them to. Teach you what graphing needs to be done. That will be all for this question. Then, what is the area bounded by the graphs? Now, hopefully, nobody misinterpret as all these three you have to draw simultaneously and then you have to get to the area. These are three basic shapes that you have to be familiar with, or you should know. The first one, see, if you don't know what shape is coming up, plot a few points and then you'll see. Hopefully you'll see the 4 corner points for the first graph are going to be 10, 0, minus 10, 0, 0, 10, and 0, minus 10. It will be a rhombus created this way. It will be a rhombus created this way. And therefore, the area bounded by the graph. See, for rhombus, the diameter is, sorry, diagonal is 20, diagonal is 20. The area is going to be half into d1 into d2, which is 20 into 20, which gets us to 200. For the first one, the area is 200. Now, for the second one, conceptually, understand, all we have done in terms of movement from the first to the second cases, we have moved the origin point. Previously, our origin point was 0, 0. We have essentially shifted this rhombus to have an origin of 2, 3. It will still be a same rhombus. Therefore, the area under the graph will be identical. Answer to the second question is also 200. Answer to the second question will not change. The graph will remain the same. Only the origin has shifted. Now, for the third one, we may not be seeing this very well, as in the shape may not be very easily visible. So see what you should be doing. First, of course, we have this x, y. Can I take 5 and 5? Can I take 5 and 5? Very much so. 1 point is identified. Can I take 5 and minus 5? X plus y will cancel out. X minus y will give me 10. Yes, 5 and minus 5 is fine. Can I take minus 5 and 5? X plus y will cancel out. Minus 5 minus y will give me 10 again. Okay, minus 5 and 5 is fine. Additionally, can I take minus 5 and minus 5? Also possible. This will give me minus 5 plus minus 5. This will become 0. These two will give me minus 10, which gets me to 10. So 4 corner points are identified, but we don't know how the graph would come up. So let me make more points. Let me identify more points. Let's take y as 0. So I'll have mod x plus mod x. So I can have x as 5, or I will have x as minus 5. Both of these are possible, which gives me the indication at 5, I'm getting y equal to 5. And at 5, I'm getting also y equal to 0. At x equal to 5, I'm getting y equal to 5. And at 5, I'm getting y equal to 0, which means throughout this range, it is going to be a straight line, which should give you further indication. Let's say if I took this as 5, 0, this as minus 5 and 0. Can you see? For x equal to 0, you could be at 5 or you could be at minus 5. This line gets created. Okay. Now putting down y equal to 5 again. Sorry. Y equal to 5. Sorry. These two lines are not correct. Y equal to 0 is the x-axis line. So if I put down x equal to 5, x equal to 5, x equal to 5, y can be 0. This point is also satisfying it. And if I put down this point is also satisfying it, this point is also satisfying it, this point is also satisfying it. We have what are these points? Now, let me go. Would it work if x was taken as 5, and y was taken as 1? Would it work? 5 minus 1 would give me 4. 5 plus 1 would give me 6. 4 plus 6 does give me 10. So this is also an acceptable point, which should give you an indication. This will now be a straight line. This will now be a straight line. This will now be a straight line, and this will now be a straight line. Essentially a rectangle of dimension 10 by 10 has been created. This is 5, this is 5. And therefore the area bounded by the graph here will be 10 into 10, or the area created here will be 100. This entire process of writing it down. See, I know x minus y mod plus x plus y mod equal to 10. A rectangle of side 10 will be, or a square of side 10 will be created. A square of side 10 will be created. But in case you don't know, list out the points and then see behavior, then see how movement is happening. Based on that, you can come up with the diagram. Similarly, let's say for the first one, if we did not know, we can have 10, 0, 0, 10, minus 10, 0, and 0, minus 10. These points are identified. Now, if I take x equal to, if I take x equal to 1, y would have to be 9 or minus 9. So there is going to be a point of x equal to 1, y being 9 or minus 9. These 2 points are possible. Or if I take x equal to 2, y will have to be 8 or minus 8. The next point identified is here, which should give you an indication of the sort of line that will get created is this way. But this was when I was taking x as a positive number only. Sorry. I keep messing up because I know the diagrams beforehand. Here and here. Similarly, here and here. One line will be created here. One line will be created here. Now, this is when I was taking x as positive. If I take x as negative, similar 2 lines can get created here also, which will then lead you to the realization that a rhombus is getting created. Now, this is for the first iteration. First time you're solving it, these learnings should come to your head. But after that, recognizing these diagrams, recognizing these mod diagrams should happen very instinctively. It's very much like when you hear, let's say, a prime number raised to the power 7, instantly you know it has 8 factors. That is how the shapes of these diagrams should run in your head because they are that common. Okay. Next question. X minus 1 by 3 is less than equal to 5 by 7, which is less than equal to x plus 4 by 5. Okay, how many integer values of x satisfy this? So you have to look at the first 2 expressions. X minus 1 by 3 is less than 5 by 7. So 7x minus 7 is less than 15, or 7x is less than 22, or x is less than 3 point something something. First 2 gives me this upper limit for x. Then we have 5 by 7 less than x plus 4 by 5, which gives me 25 by 7. Right, 25 basically. 25 is greater than 7x plus 28. Bring it over to this side. 7x has to be greater than 3, or x has to be greater than 3 by 7. X has to be greater than 0 point something something. It has to be greater than 0 point something something. It has to be less than equal to 3 point something something, which gives me 3 acceptable values of x. Have I made a mistake here? Yes, I have. This will not be 3. This will be minus 3. The option 3 is not present at all. This will be minus 3. So x is greater than minus 0 point something something. So if x is less than 3 and x is greater than minus 0 point something something, the acceptable values of x are 0, 1, 2, 3, or 4 values x can take. 4 integral values x can take. The correct answer is option D, 4. Next, how many integers a are there such that 9x square plus 3ax plus a plus 5 is greater than 0? Essentially, this has to x as in the roots are unreal, which means b square minus 4ac should be less than 0. B square is 3a whole square minus 4 into 9 into a plus 5. This should be less than 0. So 9a square minus 36a minus 180 should be less than 0. I can get rid of 9 from every term. A minus 4a minus 20 has to be less than 0. Now, here, if I try to use factorization, it will not be very fruitful. It will not be very fruitful. What I can instead do is do this, completing the squares idea, minus 4a plus 4 minus 24 is less than 0, or a minus 2 whole square should be less than 24. A minus 2 whole square should be less than 24, which now will give me acceptable values of a. A being equal to, uh, let's see, a being equal to 0 works, a being equal to 1 works, a being equal to 2 works, a being equal to 3 works, a being equal to 4 works, a being equal to 5 works, a being equal to 6 works, a being equal to 7 does not work. A minus 7 minus 2 is 5, 5 square is not less than 24. So this limit is identified. But then we had started off with this point. We go even further back. A being equal to minus 1, minus 1 minus 2 whole square is 9, works. A equal to minus 2, minus 2 minus 2 whole square works. A equal to minus 3 will not work. So the acceptable values of A are going to be in this range. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 values, or option C will be the right answer for this question. Okay. Next, the range of values of x which satisfy the inequality x square minus 17x plus 72 by 2x square plus x plus 18 is greater than equal to 0. The range of values of x where this is satisfied. Now, can you see that here this is an as in the roots here will be, the roots here will always be, the roots here will always be unreal imaginary, because b square minus 4ac. For the denominator, b square minus 4ac, 1 minus 4 into 2 into 18, this is less than 0. So this quadratic at the bottom will always be positive. So something that is always positive has to be greater than 0. That numerator also has to be positive. If I can break it down, will be x minus 8 and x minus 9. Whole thing divided by something positive has to be greater than 0. Just for the numerator, the graph would be something like this, moving through 8 and moving through 9. So every value after 9 is fine. Every value after 8 is fine. At precisely 8, we will get 0. At precisely 9, we will get 0. But anything after, anything lower than 8 and anything greater than 9 would be acceptable. And therefore, the correct answer to this question will be option A. Next, how many natural numbers satisfy the condition? X plus 10, x plus 7, x plus 4, x minus 4, x minus 7, so on and so forth. First thing you do is you write down the behavior change points, which are minus 10, minus 7, minus 4, 4, and 7. Now see, this is a polynomial with a power of 5. Polynomial with a power of, sorry, with a degree of 5. With a degree of 5. With a degree of 5 and a positive coefficient of term that has x raised to the power 5. So the shape of the graph will be something like this. This is how the shape of the graph would be. Cutting through at precisely 4, cutting through at minus 4. Because these are roots, this is where the value of 0 will be obtained. Now the question asks me how many natural numbers, for how many natural numbers will I get a value less than 0? The natural number range starts from here, 0 onwards to this place. In this range, the only two spots where it is less than 0 will be this 5 and will be this 6. For values of 5 and 6, will it be less than 0? From 0 to 4, everything is positive, and after 7, everything is positive. So for how many natural numbers this condition will be satisfied? There will be only 2 natural numbers. Last question. If x is less than y, then which of the following is always true? Now, you can do good number fitting. You can do good number fitting to arrive at your answer. Let me do good number fitting. See, if I take x as 0 and y as 10, if I take x as 0 and y as 10, first option will be 0 is less than 5 is less than 10. This holds. That does not mean this is the answer. That means I cannot reject it right now. But how about B? It gives me 0 is less than 0 is less than 10. Can you see this is not true? 0 is not less than 0. This goes away. Similarly, option D is 0 is less than 0 is less than 10. Again, this is unacceptable. We can get rid of this. Or here, I will have 0 is less than 100 is less than 10. 100 is not less than 10. This is also unacceptable. B, C, D get ruled out. And therefore, by extension, what is remaining is A. Otherwise, you can also look at option A. You can also look at option A and see a very wonderful thing. X plus y by 2 is AM, arithmetic mean. Arithmetic mean has a property that it is always greater than the smallest value, and it is always lesser than the largest value. Given that there are only 2 values and x is the smallest and y is the largest, this relationship always has to hold true. By theoretical understanding also, option A will survive, and that will be the answer. And that is the end of questions for this week. Hopefully we learned something. Hopefully at least I introduced the idea of graphing, or you could see how graphing can enable us to do work. If you haven't learned graphing, if you have skipped over graphing, I would implore you to please make sure you learn graphing. It is very, very critical for your success in this exam. That will be all for this week. See you again next time. Okay, bye.